Hi there. This video is being recorded at 3:38 on Friday afternoon. I'm super tired. I'm hoping that it all makes sense. In this lesson, we're going to cover writing linear functions given certain pieces of information. So without further ado, to write the equation of a line or the function for a line, we need two key pieces of information. So we need to anchor the line in the coordinate plane. So you got your big coordinate plane. If you have one point, it's going to fix the line to that point so it can't move everywhere. So you need a point, and it can be any point, often the y-intercept, but it doesn't have to be the y-intercept. Any point will do. And this anchors the line to a particular spot in the coordinate plane. And then you need one of two things. Either you need a second point. So if you have your first point and then your second point, that will be enough to give you the equation of a line because it'll be one line. Or you need the point and then the slope, and that will give you the steepness of the line through that point. The fastest way to write the equation of a line is to use something called point slope form. So we'll fill in that blank there. And the formula for point slope form is this. Y is equal to m times x minus x sub 1 plus y1. And you can see it's kind of blocked by my face there, but you can see where m is the slope and x1, y1 is any point. Okay, and so that's where we've got the point slope form. And when I'm typing it, there's not a great way to do subscripts when you're typing in PowerPoint. So it does look like just x1, y1. It really is x sub 1 and y sub 1. So we could also write the f of x over here. So you could say f of x is equal to m times x minus x1 plus y1. Now, this is probably a new form for a lot of you. You're used to using what's called slope-intercept form, which is y equals mx plus b. And you can also use that, but this is honestly the fastest way to get the equation of the line given information. So here's an example. We have write the equation of the line with a slope of 5 and going through the point -1, 4. So what I want to do first is actually graph it to get the picture. That's not necessary for writing the equation of a line. You could just go right to the formula, but it's helpful to actually see what's happening. So we know that this line goes through the point -1, 4. So I'm going to go ahead and plot that. That is up there, maybe. I know you guys can't see what my computer is doing. It's a pop-up keeps coming up. All right, and the slope is 5. So that means we're going to go up 5 and right 1. So if the slope is 5, we got the rise over the run. So we're going to go up 5 and right 1. For 1, 2, 3, 4, 5, and right 1, which is going to put me right up here, and there's the line. Okay, and so if you had trouble seeing what I'm doing there, it's very hard to write on my computer screen. I can't wait to get my pen. It should be at my house right now. We plotted the point -1, 4, which gave us that point, and then I counted up 5 and right 1. So starting here, went up 1, 2, 3, 4, 5, and right 1, which did put me on the y-intercept. So the y-intercept's at 9, and then that's enough to draw the line. So how does this look with writing the equation of a line? Well, we write down y equals, then the slope is 5, so I plug in a 5 for the m, and then we'll have x minus x1. Now, right here, you want to be careful because we have x minus x1, and x1 is negative, and then plus y1, which is 4. Now, just so you can see what happened here. You see we got these back-to-back negatives. One of the negatives comes from the formula right there. So we have the minus. This other negative came in on the value for x. And so we have minus a negative. Now, that is just a really, oops, bring my pen back. That is my pen. There we go. Messy way of writing x plus 1. If you subtract a negative, you are adding. Now, technically, you can stop right there, okay? If the directions are write the equation of line, you can stop right there. Now, just for funsies, though, we're going to change the form of this. So what I'm going to do is I'm going to do a line and say stop. Okay, so you can stop right there, but you can go ahead and distribute the 5. Okay, so what I did right there was I distributed the 5. So we have 5x plus 5, and then 5 plus 4 at the end is 9. And now you've got it in what's called slope-intercept form. Okay, so that is slope-intercept form, also known as y equals mx plus b. Okay, that's the name of the form. And if you look at it, it says that the y-intercept is 9, and that matches what we have over here on the graph when we counted up 5, right 1, and then of course the slope is still 5. Okay, and I want you to see that because it's actually sometimes, well, depends on what the numbers are. It can be easy to get into slope-intercept form, and all it is distribute, and then you'll have the two numbers to add at the end. So that's how you can write the equation of a line given the slope and a point. Now, what if you have 2 points instead? Because earlier I said you need a point and you need the slope. Well, what if you are just given the 2 points? Well, you have to find the slope first. And we can find the slope 2 different ways. So I've got -3, 4, which is going to be right here, and 5, -2, which is down here. And so here's where the line is, connecting those points. I'm doing this with the mouse. It's a little bit nicer. And we can find the slope 2 different ways. So one way we can find the slope is by counting. That presumes that I can find my cursor. There it is. So I'm going to count from getting to one point to the other. And it looks like we are counting down 1, 2, 3, 4, 5, 6 units. So that is down 6. And we are going to be counting to the right 1, 2, 3, 4, 5, 6, 7, 8. And so we are counting right 8. So if the slope is rise over run, it is -6 over 8, which simplifies to -3 over 4. Okay, that's one way you can do it. Or you can use the formula for slope. So the formula for slope is y2 minus y1 over x2 minus x1. So that would be, I don't know what we'll do here. We'll call this point. We'll call this point 2 and this point 1. So we will have -2 minus 4 over 5 minus -3. Again, we have that weird double negative thing going on there. -2 minus 4 is -6. And this, of course, would be 5 plus 3 because minus a negative. And you'll notice that lands me in the exact same spot. That's a 4 right there. Okay, I know that got a little bit messy. So you could count it, or you can use the formula, and notice when we use the formula, we do get the same thing, the -6 over 8. And I'm sorry, my 4 got really messed up in there, but it is -3/4, same as what we had before. Now, to write the equation of a line, then we can use point slope form. So that is m times x minus x1 plus y1, and you can actually pick either point. So you can pick point 1 or point 2, whichever one you're happier with. I'm going to go with point 2 on that. I'm going to pick the 5, -2. So we'll have -3/4 times x. And the reason I did that is because I could just subtract the 5. If I don't, I have to do like x minus -3, and I just don't want to deal with that. And then the y value is -2. And I would stop here. And the reason I would stop here is because to change the form of that, you would distribute. So you'd have -3/4 x, and then you'd have to do -3/4 times -5, which would give you +15/4. And then to add +15/4 to the 2, you would need to find a common denominator. So it's definitely kind of messy. You could do it, but it's going to be messy. So I would say stop right there. Like, just, you don't have to do more than that. So now if you're doing this from home, I want you to pause the video right here and I want you to try to do this one. So pause the video and in your notebook, try to find the equation of that line going through those 2 points. All right, I hope you did that, okay, and you're not doing what students do in class, which is just wait for Miss Taylor to do it. All right, so we're going to write the equation of the line. Now, I'm going to go with the formula on this one, but you don't have to. You could sketch, okay? And I'll make this point 1 and this point 2. So y2 is 0 minus negative, nope, I skipped my line there. 0 minus 3. There we go. Over 4 minus negative 2. So 0 minus 3 is negative 3. 4 minus negative 2 is the same as 4 plus 2, which is 6. And 3 over 6 is 1/2. So we have a slope there of negative 1/2. Okay, and you can kind of see, like, is that what you got? Did you do it by counting the points? Did you get positive 1/2? Did you get 2? Did you get negative 2? Like, what are the different things that you might have gotten wrong? And take a moment, pause the video if you need to, and just fix your mistakes. Now, to get the next part, okay, we have y equals m times x minus x1 plus y1. And we have 1/2, and we need to pick a point. I'm going to go ahead and pick point 2 because I like zeros. I think zeros are awesome, and I also like the fact that the x is positive. But you could pick the other point, and maybe I'll do it both ways so you can see it. So this would be x minus 4 plus 0. And then if you want to distribute, this would be 1/2 x. And the distribution is not too bad on this one because you just need to take half of 4, and half of 4 is 2. Yay. Now, let's say you picked the other point. Okay, so you have y equals negative, oh, that should be negative 1/2. Oops, dropped the sign. So negative, which means that makes that's a positive 2. Okay, caught that. All right. So in this case, we would have x minus negative 2. Okay, so I'm not super thrilled with that. Plus 3. So this would be 1/2 x plus 2. Okay, and now we've got to do this. So we'd have negative 1/2 x. Half of 2 is 1, and it'll be a negative 1 because it's a negative times a positive. And then negative 1 plus 3 out at the end there would be positive 2. And notice that they are the same. Okay, so it does not matter which one you picked. So you don't have to do it both ways. You just have to do it one way. And you could have found the slope by counting. Just if you do that on your test, I want you to show me how it is that you're finding stuff. I don't want to see a negative 1/2 just appear. Okay, so you have to show me what you did to get the negative 1/2. And okay, and you can see obviously that one way was much easier. So it was much, much easier to pick the 4 and the 0 than the negative 2 and the 3, but you do end up at the same spot. So something that you should get when you're doing your practice work is that experience of figuring out what's the easiest way to do this. All right. So I want to look at an application problem. Now, I kind of like the word application problem more than word problem. Word problems have words, but they don't necessarily have any use. Like they're just kind of random words. An application problem should have an application. It's going to have words too, but it's going to relate to something. So we have Pamela picks up where she left off in her book and starts reading. After 2 hours, she's on page 195. After reading for 4 hours that day, she's on page 297. So what we don't know is where she starts reading. She picks up where she left off. So we don't know where that is. So we can't assume that she read 195 pages in 2 hours because we don't know that she was starting the book. But we know that after 2 hours, she's on the 295, and after 4 hours, she's on to 97. So what we can do, well, first of all, we want to know how many pages does Pamela read per hour. And what we know is that she was on 195 after reading 2 hours, and then after reading 4 hours, she was on 297. So what we know is that in that 2-hour interval, she went from this page to this page. So 297 minus 195 is 102 pages, and it took her 2 hours to read 102 pages. So how much did she read per hour? We need to do 102 divided by the 2 hours, and that is 51. So 51 pages per hour. Okay. So we have like some weird time intervals there, but if she's reading at a pretty consistent rate, that's the numbers we have to work on. So what page will she be on after she's read for 5.5 hours that day? So we know that after hour 4, she was on page 297. So after hour 5, okay, she would be on page 297 plus 51, which puts her at page 348. And then it's going to be a half an hour. Okay, so we don't want to add the 51. We want to add half of that. So I don't have any space to do this. So 51 divided by 2. So that is 11, and okay, so 25.5. So we're going to take our 348 and add 25.5. So that's 373.5. And what I'm going to say is she's going to be on page 374. Okay, she's going to be on page 374 because it'll be 373 and then half, so she'll be about halfway through the next page. Now, the third part there says write an equation that gives the page she's on X hours after she starts reading. So we got to kind of figure out what's going on here. So here's our template. Hello. And the slope is the pages per hour. So we got 51, and then we need to pick one of our points. So I want to keep the numbers as small as possible. And so I'm going to use after 2 hours, she was on page 195. So I'm going to use that. So X minus 2 plus 195. And then you could stop there, or we could keep going and say, what is this? Minus, we just did that, minus 102 plus 195, and then combine those. I'm sorry, I'm going to go up to the upper left hand corner of your screen here to do 195 minus 102, which gives us 93. So it could be y equals 51x plus 93. Okay, now that was like a lot. So you might want to rewind. I've been on this slide for about 5 minutes. So you might want to rewind the video about 5 minutes and like kind of get that again, what we did. Application problems are challenging. I do expect you to try them. And if you train wreck, that's why we have homework review. Okay, but be ready to share what you did. So in class, be ready to share what your attempt is, even if your attempt is unsuccessful, because this is how we learn. All right, so that brings us to the practice set. So for the practice set, the first 4 problems are just write the equation of a line. So those are your very straightforward. The first 2, you have the slope and you have the point. So you just plug it in and simplify. The second 2, problems 3 and 4, you have to find the slope between the 2 points first. Then for number 5 is a little bit exploratory. So plot those points, Can you find the slope and the y-intercept from the graph only? Can you do it without using any formulas? What are they, and what is the equation of the line? So try to, problem 5 is like, can you figure out another way to do it? And then 6 is going to walk you through an application problem. So a 4-topping pizza costs $18.99. A 6-topping pizza costs $22.49. What is the difference in cost? What is the cost of each new topping? So you're going from 4 toppings to 6 toppings. How much did it go up per topping? How much would a 7-topping pizza cost? And then let the number of toppings be X and the cost be Y. Write an ordered pair for the information you have. And then write the equation of the line, and what does the slope represent, and what does the y-intercept represent. Now, I'm expecting you to ask questions on this. If everybody comes in and no one has a single question, like something is totally wrong, okay? So I'm expecting you to ask questions. That's totally fine, but also have something written down for every single part of the problem, like as far as you think you can go. All right, you guys know where to find me. I'm sorry, got a little bit noisy in here. The janitors are, cleaning. So now it's like close to 4, and I'm gonna start grading these before I leave for the weekend. And I hope you're all having a wonderful weekend or had a wonderful weekend. See you guys later, and you know how to reach me.